Let's plan our state variables. Every auction has an owner. The owner is the account that deploys the contract and the person to whom the winning bid will go if auction completes successfully. We can separate the admin, that's the account that deploys the contract and has more permissions, from the beneficiary being the person or the contract to whom the funds will go if the auction completes successfully. At this moment, we don't separate the admin from the beneficiary and we only have an owner. Address, public, owner. I'll declare all state variables as public because this way it is easier to access them when testing the contract. Auctions also require a start and an end time. Time in Solidity is very tricky. Block timestamps are set by miners and can be easily spoofed, so it's not safe to use block timestamp. An emerging best practice is to calculate time based on block number. We know that Ethereum blocks are generated roughly every 15 seconds. So, having this value, we can calculate the start and the end time. Let's have an example. Let's suppose we want our auction to last 1 hour. This is just an example. We know that every hour 240 Ethereum blocks are mined. So my auction will end after 240 blocks. So I declare an uint variable start block, another uint public variable named end block. These two variables will be used for calculating start and end time. It's not cost effective or scalable to save information about the product or the service that is sold in this auction on the Ethereum blockchain. Saving a single byte of data on the Ethereum blockchain costs 5 gas. A recommended solution is to use the IPFS or the interplanetary file system for saving a large amount of data. So our product information, photos and so on will be saved on the interplanetary file system, and on the Ethereum blockchain using a state variable will save only the hash that uniquely identifies my information on IPFS. String public IPFS hash. We'll talk about the interplanetary file system in a bonus lecture. I'll also declare an enum variable for auction state. My auction can be in running state or can be cancelled or could have already been ended. Enum state. What are my auction states? Auction can be started, can be running in the running state, ended, and let's say cancelled. The owner can cancel the auction if something bad happens or if he simply wants. And now I declare another state variable of type state, my new enum variable. This is public and the name of the variable will be auction state. We'll save the highest binding bid in an uint variable, so uint public highest binding bid. The highest binding bid is the current auction price. And we have also an address, a public address, where we save the highest bidder. We'll save all bids in a mapping variable, so mapping, the keys are of type address, and the values are the amount of way the bidder sent to the auction. And the name of the variable is bids. So if somebody sends, let's say 1 Ether for this auction, I'll register his address as a key of the mapping, and the value associated with that key will be 1 ether in way. So this variable holds every value sent to my auction with the address from which it came. These are my contract state variables. Maybe we'll add other variables, but till this point, this is enough. Now let's define the constructor. The constructor will initialize the state variables with its arguments. So, constructor, and now constructor arguments. uint start block, uint end block, string underline IPFS hash. Here we have an underline 2, uint underline bid increment, and I think these arguments are enough. Public, and now the constructor body. I'm initializing the owner with the account that deploys the contract, so owner equals msg.sender. The auction will be in running state, so auction state equals state my enum variable dot running. This is how we initialize an enum variable. And then we have the other state variables. Start block equals underline start block, and block equals underline end block. IPFS hash equals underline IPFS hash, and bid increment equals underline bid increment. Okay, I forgot to declare a state variable named bid increment. So here, unsigned integer bid increment. I'll explain you more about the bid increment variable in the next lecture when we implement the place bid function. When deploying the contract, we must specify here the constructor argument. So the start block, I don't know, it's just an example, this block, end block, this value from here. Then we have the IPFS hash. We write it between double quotes, so it's a hash here, and so on, and the bid increment, for example 10. Okay, and the contract has been deployed. We can see here our state variables. This is how this contract will be deployed. But in our example at this moment, I want to modify the contract because it's complicated every time when I want to test something to write all these arguments here. So only for our example, I'll delete all arguments from here and I'll hard code the values. So it's easier. For example, the start block is this block. If I want the auction to start immediately, so block dot number, this is the current block, IPFS hash, let's say an empty string, and bid increment, let's say 10. Okay, let's suppose we want our auction to be valid for 1 week. What does 1 week mean? Let's see how many seconds are in 1 week. So 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. This is the number of seconds in a day multiplied by 7, the number of days in a week. So this is the number of seconds in a week. And I divide this value by 15, 15 being the Ethereum block time. So we can say that in a week, 40,320 Ethereum blocks are mined. So my end block will be the start block plus this value. This means that the auction will be in the running state for a week. Now it's much easier to test different small things and to try different features. So for example, if I want to deploy my contract, I simply press here on deploy and the contract is deployed and my state variables have these values from here. Maybe you think that it's strange for an end user to enter the block number instead of 1 week. There is no problem. The end user doesn't have to know about Ethereum blocks and block time and so on. The end user will enter the auction end time and the front-end interface will calculate all the math behind.